Hi, and welcome back to another part for our SQL database application. In this section, we're going to continue on with table joins. So if you've been following along, we're here at the end of row 2 of our contents. So table joins is what we're going to be working on. You can see that we still have 4 more subjects that we're going to cover, and by the time you're done, you'll be an expert with working with SQL databases. My name is Shad Sluter, and I teach software development at Grand Canyon University. And you're in the middle of a process of learning how to write SQL applications. So let's take a quick overview of where we're going to be by the end of this video. So what you see on the screen here is the database of our songs, and as you can see when I click one of the album titles, the rows below show us the tracks. Now this is different than the previous lesson that we did. You can see that the track titles here include things like the album title, and it's listed 3 times here for, in this case, the word help, and then you can see the others show the same results. So what we're going to do is have custom headers for this bottom table. So you can see that there's more table headers here than are actually saved in the database. So how are we going to do that? Well, it's through the magic of joins. So the first part of this tutorial is to work with the MyAdmin tool to create the joins, and then to be able to put them into the application as you see it here. So let's get to the first part, which is what is a join? So let's jump back into the tools where we were designing 2 different tables and connecting them with a foreign key. So look at this example here. So we have tracks as one table and albums as the other table, and this link, the foreign key, shows us that these 2 tables are related based on a number that's saved in each of these columns. So the albums underscore ID value here on the right always matches with one of the numbers in the ID column of the albums table. That's the foreign key, and we're going to use it to create joins. So I'm going to jump now into the PHP MyAdmin page, and you can see that I have the tables for albums and tracks listed here. So we have contents in both tables, so there's actually values to be able to search for. Now I'm selecting the tracks table, and then I'm going to the SQL tab, and we're going to write a select statement. So let's click on the word select, and you can see that we have all of the column names listed for our suggestion, and then it says here from the tracks table. Let's choose the go button and just check to see if it's actually working. And so it says we have 11 different items that have been selected. So now let's experiment with changing this select statement into a join. So I'm going to select again, and then I'm going to put in something at the very end. So I'm going to get rid of the where clause for a second, and then I'm going to say join. So there is a join, and now I'm going to tell it the name. So the albums table, and then you have to say the word on. So after the word on, then you put in the name of the foreign key. So if I type in here albums ID, and then you're going to say equals albums, and then you have .id. So that's telling it which items in the table contain a foreign key and to which one it's associated with. So how did I know to use those 2? Well, I have this diagram in my mind where I see that albums underscore ID is supposed to equal albums.id, which is the item on the left. So it's always a good idea just to check to see if you've written everything. This will not change the results here, but I just want to make sure I haven't caused an error. So I'm going to check retain the box and go. And sure enough, I do have an error. Let's see if we can understand it. It says down at the bottom, it says column ID in the list is ambiguous. Now that's an ambiguous error. I don't know what you mean. What that means is that there are 2 tables here, and both of them have an ID column. So if you look at the diagram, you can see that right away. So tracks ID and albums ID are both called ID. And when we join tables, it really wants us to be very clear to say which table we're talking about. So let's do that. Let's specify which table. So let's scroll up, and the problem is occurring here where it says select ID. So it doesn't know which table to get it from now because we can select from both tables. So let's put in here the word albums, that's the name of the table, and then .id. So that will be one selection. We could also say, give me the tracks.id, and that is also valid. Let's do the go button now and see what comes up. So now the results are valid. You can see that it says ID and ID, and we can't really tell which one is which. So this is a case of being ambiguous. It would be easier for us to understand the results if we didn't have just the word ID. So since it is kind of difficult to distinguish the two, I'm going to rename them. So I'll say select albums.id as, and then I'll put a new label. And a good name for this could be album ID. And the same goes with the track ID. Let's now rename it as, again, using the keyword as, and we'll say tracks.id as track ID. Now let's go again and see what that does. So scrolling down, I see the results, and now it is very clear to say I know that the first column is the album ID, the second column is the track ID. That makes more sense. So the neat thing about joins is that you can select columns from either table now, and they will show up in the results. So let's say I wanted to, for some reason, add the album title to each row in the search results. So I can just put in albums.album title. So what does that do? Let's choose go, and let's see the results now. And you can see that album title now is listed here. So every row contains the album title along with the rest of the items for each track. So we're selecting tracks, but we're adding the album title as the search results. Now I'm going to reduce the number of columns that we're selecting because that's a lot. So I'm going to remove a few things. So let's get rid of the first item, which was the album ID. Let's get rid of the number, and I'm not sure what else I'm going to get rid of, but I'm going to delete several of them to reduce it. So that way when we do the search results now, I click go, we have a fairly narrow items. So I have track title, video URL, and lyrics. So those are the results from this particular query. Now I'm going to take this query and attempt to use it in my application. Okay, so now it's time to take that SQL statement that was using a join, and we're going to bring it into the application and see what consequences that has. So what I want to do is in this form, whenever we click an album title, I get the search results of the tracks below. So right now it just shows a list of tracks, which was working, but we've changed the SQL query. So let's see what that does. So I'm going into the data access object here, and I'm going to copy the part that says get tracks for albums. So let's select everybody all the way to the last item and Control C for a copy and then paste it. Now I'm going to make some changes here, and so let's just rename this one as get tracks using join. So right now it's an identical piece of code, get tracks using join. We're going to have to change the SQL statement now. So the select statement comes from here. So we have this nice statement that does join. So before I take this one step further, I just want to add a where statement. I'm going to say where albums ID, and I'm going to put in something like a 3. So it's a placeholder. 3 is a placeholder. So let's try that out. Choose go. So the results are that every item comes from album number 3, which is Abbey Road. So that is the results because I said give me ID equals 3. So let's take this as our example. I'm going to copy that. And so now let's jump back into the code here, and I'm going to erase this select statement that was there and paste over top of it the newest version. So we've got albums ID equals 3. So the 3 isn't quite what I want. I want to have this placeholder, album ID. So that way, whatever we ask for will match the album number. Okay, so we got a bunch of columns that are selected, and then we return a track, and then hopefully we return these. Okay, so now I'm going to come back into the form 1, and I'm going to change this code here. So this method was get tracks for album. Let's see what out there is now. Let's try get tracks for album using join. That's the new method that I created. So should work, right? I'm selecting. Let's see what happens when I run it and what surprises might await me. So I run the application, I choose load the albums, and then I'm going to select help, and we got a problem. So you can see here that the track has 5 different properties, and when we did a select with a join statement, all of a sudden we're selecting like 6 or 7 column numbers. So you can't just say put these column numbers into the properties of the track object anymore. They just don't match anymore. We can't use this process as it's written. So I'm going to fundamentally change what this method is supposed to return. So right now it says give me a list of tracks. That's what the return value is on line 169. So what I want now instead is something called the J object. And let's see if we can do that. It's probably going to cause a problem. So I type in JObject, and sure enough, it says I have no idea what you're talking about. So a JObject is something working with JSON text, which is a very flexible way to create objects. And C# doesn't automatically know how to work with JSON. You have to install a library. So let's go down to the package installer. It says Newtonsoft JSON, and we'll install whatever it says is the most current package. And the error goes away. Now let's check to see what was installed. So I'm going to right click and choose Manage NuGet Packages. And let's check to see, yep, sure enough, we got Newtonsoft or Newtownsoft, and it's installed here at version 13.01. So now instead of returning a bunch of tracks, I need a bunch of JObjects. So down here in the reader area, we're going to expect to add a new item which is going to be of type JObject. So you're going to see what a JObject is in a minute. I'm going to print it so you can actually see them. So for right now, just let you know that it's a very flexible object. It's kind of like making a track object or an album object, except it has a flexible number of columns and properties. So we're going to create a new one. It's called new track, and then I'm going to add it to my list of return items. So it says here you got a problem. So new track is not the right type. So let's scroll up a little bit. And I have a list of things called tracks here, and let's change that to JObject. And that way will it be compatible. Okay, so return these is of type JObject now. Okay, so the errors go away. We're not quite done. We need to get all of the properties from each column name yet, and so that's what we're going to do here. Okay, I need to cut that out and put it in the while loop. So we're going to make a new object and then add it to the list. So for each column that I select or each column that I read, I'm going to put it into this JObject. So I'm going to make a for loop. And I'm going to say go from for I equals 0 to the length or the field count of the reader. So the reader read a row and it has a bunch of columns in it, and the property called field count tells me exactly how many columns there are. So it's a flexible amount. Now I want to add some rows, or I want to add some properties to my new track object here. So I'm going to say new track.add. Now we need two things. We need a property name and a property value, and we can get those from the reader. The first is to get the reader's name property for this thing. So let's say reader.getName at column I. So I goes from 0 to the number of columns, and so that will be a string. That will be the first half of the property. The second half is the value. So to get the value, we have a similar item. We say reader.getValue at position I. So that means we have two parts to each column. We have its column name plus its property value. All right, so check all that out. I think we got the columns all correctly now. So this will be flexible for the number of columns that we're reading. And then we're going to return it to our other part of the application. So let's go to Form 1. So now we come back into our Form 1, and let's see what happens when I run this. So now I click on Load Albums, and I get everybody, and I click on Help. And this time you can see that the select statement is only selecting a few rows. So we have fewer items across there, but they're flexible in number. So if I change the columns that I'm selecting, the bottom table should be flexible as well. So let's test out that theory. So I'm going to come back down to here, and I'm going to, for whatever reason, I'm going to leave out the lyrics. So let's just delete lyrics. And we have one less column. Let's run it and see if that is as responsive as I promised that it would be. So here we go. Let's load the albums, and we try help again. And sure enough, the lyrics column is gone. So I just didn't need it for this part of the application. So you can add more columns and subtract columns to the magic of this JSON object. So this is not only a lesson here in running SQL, but a little bit in C# and how JSON text is handled. So JSON's pretty common. You can see that the advantage is that you're no longer tied to the static number of columns in a thing like this, like the track, or if we created a custom class called a data transfer object, or a DTO, which takes the number of columns into effect. So JSON was invented to work with JavaScript, but all other languages, including C#, have adopted it, and you can see the flexibility of it. So we've moved on to another section, so let's get to the bottom row now and continue learning about our SQL applications. We're going to talk about UML diagrams and how they are used in design. That's coming up next.